This conference will now be recorded.
Yes, we can see it,
Right.
Paul.
Great. Thanks, Liam. Thank you all for attending. What I'm going to go through today is just a quick overview of the common safety method for risk evaluation and assessment. And specifically, I'm going to talk about how we apply it to infrastructure upgrade projects. Okay, so without further ado, those of you who did notice that there was a change of lecture tonight, on the PWI website, will have seen this resume of the presentation. So what I'm going to do is I'm going to talk about CSMRA. I will not go through calling it the Common Safety Method for Risk Evaluation Assessment ad nauseum tonight, because we abbreviate it to CSMRA. It makes things a lot easier to say and understand. And I'm going to just explain how it applies when a proposer of change is proposing to make change to any part of the railway infrastructure. And by this, I think for the PWI, the general impression of railway infrastructure is effectively tracks, switches and crossings, track as a structure, track substrates, structures, that sort of thing. But in the systems engineering world, the term infrastructure, in effect, to be very simple about it, it refers to anything that doesn't move. So I will be going into areas that you probably don't necessarily may not have much experience of, but I'll sort of hopefully go through that and try and explain some of the key principles of what we're trying to look at that point when I go through that. So what I'm going to do is start giving an insight of what CSMRA is, where it links in with legislation. That's very important, but I don't really want to be spending too much time on that, because I think this is a presentation that is more tailored towards the engineers and some of the interesting quirks of working with infrastructure projects and applying the CSMRA to them. So I'll go through a few examples of experiences through the CSMRA process, and then towards the end of the presentation, what I'll do is I'll just expand a bit, because the CSMRA fits in with Network Rail's requirements and Network Rail authorization assessment panel activities that regulate the introduction of new technology and change to the infrastructure. So next slide. Okay, just give you an overview of what the CSMRA is. It's an EU regulation. It was initially introduced in 2009 in its first form, and later amended in 2013. The current version of the CSM regulation dates from 2015. So in effect, we've had 6 years, perhaps a bit longer, experience in really implementing it in the UK. It's basically a regulation that aims to deliver a high level of safety on the European railway system. It aims to facilitate acceptance of change across the whole of the European member states, and also basically to introduce a level playing field so that all of the member states are in effect operating to the same procedures. So a product or an infrastructure change that is accepted in one member state, the process by which that acceptance has been undertaken is valid in the other member states. So it's removing the barriers that might otherwise be put up between member states. Okay, very important bullets here. The CSMRA applies, or just consideration of the CSMRA applies when any changes made to the railway system that impacts on safety. Now, in terms of tonight, the presentation will concentrate on technical changes insofar as we will be making changes to the infrastructure, but there might be an assumption that there aren't any other changes that occur. However, for major schemes, you may well find that they take place in conjunction with an operational change. So you might be introducing a new timetable to make use of increased capacity on an upgraded network or an upgraded stretch of line. So it will cover you did consider the impact of the CSMRA with regards to the operational changes that will be made. And one that gets forgotten, I think it's the CSMRA also applies for organisational changes. So what do we mean by that? Well, I think a good one would be when maintenance activities or renewal activities that were previously delivered in-house are then pushed out to the supply chain part of the industry, elsewhere in the industry. So you're in effect, as an infrastructure manager, potentially discharging or attempting to discharge your safety responsibilities to a third party or third parties. And you will have new teams, you'll have new management structures that come in that may have an impact on safety. Same in internal restructuring. If you have a major delivery section within your organisation, you decide to make the local teams more responsible for the delivery of the services that facility provides, you may well be looking at a change that has an impact on safety, and therefore you would need to assess it under the CSM regulations. Okay, there are a number of common safety methods. I won't go into all of them. CSMRA is just one of them. There's a common safety method for monitoring, supervision, safety targets, and conformity assessments, amongst other things. But we are going to concentrate on the common safety method for risk evaluation and assessment tonight. And this specifies a risk management process which applies only when the change is significant. However, there is an exemption for that, so an exception to that, and I'll briefly mention that later in the presentation. Okay, notice about Brexit. Obviously, this is an EU legislation. However, just because we've left the EU, it doesn't mean to say that we do not need to comply with it, because when we withdrew from the EU, we absorbed CSMRA into UK legislation. So for the time being, it is still a requirement for us to comply with the requirements of the legislation. Okay, so no change in the short term. Okay, just a quick overview of general safety legislation that all organisations need to comply with. Health and Safety at Work Act has the requirement that it is an employer's duty to assess and reduce risk so far as is reasonably practicable. So it is a practice that is already well established. Risk assessments are sort of business as usual stuff for any organisation, and any organisation that makes change or infrastructure change, building activities, construction activities, also needs to comply with the construction design and management regulations, which cover an employer's duty to carry out work safely. Okay, so part of this means by which these controls are implemented by an organisation is often, usually through a safety management system. And the next slide, I'll also sort of mention that the safety management system is a requirement of the Railway Safety Directive. So CSMRA is actually forms a small part of the safety management process. It it's effectively what it does. Compliance with CSMRA enables sort of a commonality to the approach to risk management, risk identification and management. And it also provides sort of a common framework for documenting and providing justification that can be assessed through independent assessment later. So it is effect. It shouldn't, and this is quite an important point. If it's embedded within an organisation, it shouldn't be onerous. It should be something that bolts onto the business as usual activities, and it is a means of documenting the risk management processes that the organisation should already be undertaking. But if it's not approached from an early stage, it can place quite a burden in order to catch up and recover some of the scope of the CSMRA, which should have been undertaken earlier in the project. So, message there is to start early, and that's something I shall touch on as well later. Okay, so another sort of illustration here. Some of these slides actually I've taken from a Ricardo training course. So shameless plug for Ricardo that we do 1 and 2 day training courses which go into more detail of CSMRA, its origins, its relationship with legislation, and its application. So have a look at the Ricardo website to get information on that should you need that. Right, okay, so I mentioned earlier on the Railway Safety Directive, and that is the EU directive that legislates the requirement for railway undertakings and infrastructure managers to implement a safety management system within which the common safety method interfaces. So implementation of the Railway Safety Directive in the UK is through ROGS, so that the ROGS basically manages the national technical rules, implementation, management of safety on the railway through national technical rules, and aligned with that, we have the Interoperability Directive, which is a means by which harmonisation of railway operations and undertakings across Europe is harmonised. And if we have an interoperable railway, we do need to consider the interoperability regulations. And where we have an interoperable railway, we do need to make some slight amendments to the deliverables that we produce and the activities that we undertake under CSM, which I'll briefly touch on in a bit. Okay, frightening diagram time. This has been taken straight out of the CSMRA legislation, and it shows the process of delivering CSMRA and complying with CSMRA throughout a project life cycle, starting from the top, running through the various stages. Now, what I'm going to do is I'm not going to go through everything here because we don't have time. And as I say, we've got training courses that do that, and they've got a lot more time available to go through all of this. However, I will be picking up on some of the most important aspects of the activities. So I'll be just looking at the significance of change, because that determines what activities then have to take place in order to comply with the CSMRA. I shall then be looking at the next stages, which will be planning the risk management activities and trying to defining the scope of the risk management activities, looking at how hazards are identified and going through a few real examples of the work that we've done in that area and some of the little quirks that have come up. A little bit on risk analysis and evaluation, having identified the hazards, how you treat them, how you provide evidence that you're complying with the safety requirements that you are determining to manage those hazards, where you are documenting your hazards and how you maintain that documentation over the life of the project. And finally, at the bottom, quick note on independent assessment and the scope of the independent assessor's activities. So ultimately, having gone through that process, you will hopefully come out with a favourable outcome in terms of either your sponsor taking responsibility for the safety management that you've undertaken, or a favourable safety assessment from the assessment body. Just quick note on the two vertical bars, the independent assessment and the hazard management activities. They are both undertaken throughout the project. However, they don't commence until you've undertaken your significance assessment. So quickly go through the significance assessment. No, I won't. I'll go through some general safety legislation. I did mention first thing, the proposer of a change to the infrastructure. Basically, CSMRA has this role of a proposer, and that is the person who is taking, or the body that is taking responsibility for maintenance of the railway infrastructure, that also wishes to take responsibility for changes being made. So common, and say just infrastructure. In terms of the infrastructure, that'll be an infrastructure manager. In terms of operations, that'll often be a railway undertaking, such as a train operating company or a rolling stock leasing company. So they're more likely to be entities in charge of maintenance. Manufacturers, and in terms of interoperability, we have something, a concept known as authorization for placing into service, which is submission to ORR for to award that authorization for entry into service of the change that that activity has made to the infrastructure or operations. So I'll go into a bit more of this later. Actors are parties involved directly or via contract in the application of the CSM. So they have a role to play in the risk management process. Okay, I've mentioned the assessment body, or ASBO. The assessment body is an independent body that at various points in your project, as the project design develops and as you start to implement the project before commissioning, in fact after commissioning as well, the assessment body will be reviewing the evidence that you are providing that you are adequately managing hazards to reduce risk to be as low as reasonably practicable. And there, yes, okay. So they are accredited by a suitable assessment body as well. So okay, let's move on from there. I'll give you a bit more information then later. Okay, quick overview of the scope of the CSMRA. It applies to the mainline railways with each member state. So in the UK, that will obviously be Network Rail, or Network Rail owns infrastructure. However, there are some exemptions. Metros, London Underground is exempt from the CSMRA, except where it interfaces with the national network. Trams, Manchester Metrolink, Sheffield Trams, other light rail systems are also exempt. Networks that are separate from the railway system and intended only for their operation local of urban and suburban passenger services. A good example of that one, and something that I'm involved in looking at the moment, is the Isle of Wight, which is owned by Network Rail, but is not actually connected to the main network. So therefore, it is not subject to the requirements of the CSMRA. Nor does privately owned infrastructure solely for freight operators. These will be ports, quarry facilities, oil terminals, that sort of thing. In terms of vehicles, heritage vehicles, it's not practicable to reverse engineer heritage vehicles to comply with the requirements of of the national network that's necessarily derived from CSM. Heritage museum and tourist railways that operate on their own network. So the heritage railways, the steam railways, the tourist railways are not applicable. The CSMRA is not applicable to them, so they are able to make changes under their own safety management systems without need to comply with CSMRA. Okay, so going back to that diagram, death by diagram. This is a very complicated diagram that only covers that section highlighted in or circled in black at the top there. Okay, this is an activity that needs to take place very, very early in a project. So I'm a proposer of a change. I wish to make a change to my network for whatever drivers it might be, capacity, a technology is life expired, it needs to be updated. I want to make a change to a signaling system, but I don't really know what I want to do quite yet. So I don't have much information. All I have is I want to make this change, and it's got this sort of rough boundary between point A and point B, or it concerns this fleet of vehicles. I'm updating this fleet of vehicles, or I'm replacing this fleet of vehicles. But it's at this point that you need to determine the scope of the common safety method, the application of the CSMRA to the project. So you have this rough idea of the scope of the project. At this stage, it needs to be enough to make a decision, but you've not done any design work yet. So there is a process to determine where you go with CSM. So you will have a preliminary idea of the system, which you can document in the preliminary system definition document. And from that, it should give you enough information on the novelty, complexity, and the consequence of the failure of the change to your system. For instance, if you introduce a new fleet of trains, does it need a different type of maintenance practice? And if it doesn't happen, is there going to be a problem with the trains becoming incompatible with the infrastructure and derailing, or catching fire because there's certain parts of maintenance aren't done and filters aren't replaced, etc., so putting lives at risk. So does it affect safety? I think generally any project that introduces a change in infrastructure, 9.9 times out of 10, it will affect safety. An example of a change that wouldn't affect safety would be, say, or may not affect safety, would be, say, putting a new advertising hoarding up at a station. So as long as it's located properly, it's not providing distraction to drivers, it's not providing a hindrance to signal sighting. It's not got vast expansions of red or other lighting that can cause issues in terms of misreading signals. So realistically, you could say, actually, no, it's not going to affect safety. So what you'd do in that instance, you'd say, no, it doesn't affect safety. I'd say it's not significant. So the requirement there is record your decision and work in accordance with your organisation's safety management system. Okay, so mostly you wouldn't be able to do that. So you'd need to do some sort of significance test, which is sort of you see the matrix there on the right-hand side. That's from the ORR guidance, which is just one means by which you can undertake a significance assessment. There are other methods of doing it, but that's considered good practice and is a good example. So you would be looking at various criteria, such as your novelty and your complexity. So your novelty and complexity determines your uncertainty of what will happen, what's the outcome of the change that you're making. And equally, if you're making a change, what's the failure consequence of that change? For instance, if you're changing a signalling system, you could end up with collisions. If you're changing a track formation, you could end up with derailments. So you've got some potential for either critical or catastrophic failures with trains derailing and colliding with each other. Whereas if you're making a change to a communication system that's non-safety critical, you end up sort of delaying information exchange, but actually you've got other means by doing it, and the signalling system protects the train. So your failure consequence could be insignificant, it could be marginal. Okay, so again, you do the assessment against the matrix and come out with an assessment of either significant or not significant. You may, in this example, decide that it's not significant or significant, but you may need to apply additional criteria, such as additionality. Additionality being the concept where your change might actually be undertaken combined with a number of other changes. So your change might not be significant in itself, but with everything else going on, you need to be looking at the whole change that's taking place by all of the aggregated changes together, and that might actually be significant. So there's a concept in CSM called salami slicing, which is a practice that is absolutely forbidden, where you chop up a large change into smaller non-significant changes and treat them all as being non-significant. Okay, so again, if you decide it's not significant, you justify the decision through your preliminary system definition with your significance test, which is documented. You record that, and then you work to the requirements of your SMS. Okay, I did mention there's an exception to compliance with CSMRA. This would be when working with network rail projects. The network rail standards require any project to comply with the requirements of CSM, even if they're not significant. In this instance, the sponsor will take responsibility and accept the responsibility for the change in the safety profile that the project introduces based on the outcome of the CSMRA risk management process. Okay, so in that instance, in any other instance, your change will be significant. Therefore, you need to undertake risk management in accordance with CSMRA. Okay, quite a lot of information there. I'm conscious I'm probably rambling on now. I thought I'd get through that quite quickly, but it's taking quite a long time. This is important, though, in terms of the fact that when you are defining the scope of your change, you need to understand the boundary, what is within, what is without the remit of your, outside the scope of your change, and you define that through the system definition. Now, a system definition is a larger document than the preliminary system definition, but it can actually build on the information on the preliminary system definition. And it should provide enough context to allow the risk management or the hazard identification process to take place comprehensively, but not onerously. And also, it also needs to be able to determine where hazards are in control of the project and where they're not in control of the project, and determine where at interfaces those hazards can be transferred to other CSM actors for ongoing management. For instance, the boundaries between the CDM hazards and CSM hazards. So hazards associated with construction are not necessarily within the scope of the CSM. Okay, quick explanation of what a hazard is. A hazard exists on the system boundary, and it is the situation that has the potential to cause, that can lead to an accident. The causal factor is a circumstance that can lead to a hazard. So we've got lots of activity to take place within a system environment which have the potential to interact with each other and result in a hazard. Hazards tend to occur on the system boundaries where the change that you're making within the system has an impact on other steady state activities that interface with the change that you're making. We've also got barriers to escalation, such as standards, such as processes, such as engineering out the opportunity for a hazard to take place. So where we have a combination of a hazard and opportunity, those barriers prevent that from becoming an incident. So that's an illustration of that on the right-hand side. So it's very important to define the system boundary and the interfaces, which are numerous, include geographical interfaces, operational interfaces, passengers, workers, the public, and as I mentioned, other projects. So other projects might be interfacing with yours. That introduces the concept of additionality and other change that could result in hazards. And systems can exist within systems. And I won't go into too much detail about that because there's not much time, but I will give you an example that in effect touches on that later. Okay. Interesting. One of the interesting components of system definition is often a diagrammatic representation of the system that you're changing. This particular example is for a very large multidisciplinary station area upgrade, which from this diagram, there's a lot of information here, but it shows where you effectively have a number of human interfaces in a signaling center that interface with electronic signaling equipment, interlocking communications equipment. Towards the bottom there, you've got other things like level crossings that you interface with. You've got the track, you've got the signaling infrastructure, the trackside signaling infrastructure itself. Bottom left-hand corner, you've got the train driver, you've got passengers, you've got trains themselves. So that is an extremely complex system. In practice, you would break that down into a set of activities, risk management, hazard identification, risk management activities throughout the duration of that particular project. Okay. And this diagram would be a good way of working through this diagram, looking at the interfaces and the impact of change on the signalers, the train drivers, etc., members of the public, and just try and identify opportunities for harm to come to individuals. Okay. Combined with, say, the system definitions and safety plan, which documents the CSMRA activities that you're going to undertake within the realms of the engineering safety management, wider engineering safety management that will be undertaken. I'll go into a bit of in the next slide. I'll talk about roles because we did mention roles earlier. There are a lot of roles that have responsibilities for risk assessment under CSMRA. So I don't want to go too far into that, but it effectively defines who's going to do what, how they're going to do it, and when they're going to do it. And I mentioned that CSMRA should be undertaken throughout the project, right from the early starts, because change will happen as design progresses. You'll have more information come in. Some of the assumptions that were made earlier in the project become superseded or obsolete. More information will come to hand. You need to update the hazard identification activities that you do to ensure that as the scope of the project gets more refined, your risk management process becomes more refined, and you continue to ensure that all hazards are identified and adequately managed. Quick note about the interoperability regulations. In terms of the safety plan, this may be incorporated to project authorization strategy, which would form part of the submission to the ORR for the application for placing into service. In addition to the in Network Rail projects, the Network Rail Acceptance Panel assessment and authorization. Okay, quick note on CSMRA actors. This is another, you see on the right hand side, key project participants that are responsible for the risk management activities. So these can be at the top there, you've got sponsors, the project managers, you've got the assessment body on the left-hand side, sitting on the side there, interfacing with the project. Support might be given to the CSM safety engineer. Day-to-day operations will be, or day-to-day management will be through the scheme project manager and the designated project engineer. You've got the project operations interface specialist, which will interface between the project and the railway operational functions such as Network Rail Ops and the train operating companies. You've got the control centre. Obviously, the signallers will be impacted and will be interfaced with signallers, and they will need to be trained up to accommodate the changes that are made. Same with the maintenance delivery unit. And then at the bottom there, you've got the actual organisations and actors delivering the change: signalling, civils, construction, the project engineers who are sort of on the feet on ground. So they will be interfacing with the operational railway in their day-to-day activities. So all of these organisations and people need to be named, ideally given names, and their competence to undertake those roles and their ability to be able to deliver the CSMRA responsibilities will be defined as part of the risk management process and documentation. Okay. Next phase, having defined your boundary and the plan for the risk management activities that you'll be undertaking, you will be required to identify all reasonably foreseeable hazards. And you then will need to understand the risk that's associated with each hazard by classification and analysis. And through that, the management of those hazards to be tolerable so far as is reasonably practicable needs to be undertaken through application of safety requirements. And the evidence that those safety requirements are complied with needs to be produced to demonstrate that you have reduced those risks to be as low as reasonably practicable. Two ways of doing hazard activities mainly. Empirical means, checklists and risk assessments. You'll be doing a lot of this as part of your day job in terms of an infrastructure change project, and even a product instruction project. You will be undertaking risk assessments such as suitable and sufficient risk assessments. You'll be producing checklists. You'll be doing design assessments, that sort of thing. Also, one of the key ways of doing it is creative means, hazard and hazard workshops, whereby you get a number of qualified, competent people together to undertake reviews of the system. I'll quickly go through those, and this is documented and hazards identified through assessments of the system. And the system diagram that I showed you earlier would be a good way of doing that. We're going through that and looking at the impact on the various users and people, operations that interface with the project change, the scope of the project change. Okay. Why do we do this? We want to stop this from happening. Hatfield, October 2000. The whole point of this is really to make sure that the hazard that led to this, which was loss of support train guidance. Quick note on 802, the Rail Safety Standards Board has the safety risk model, which is a database of many years worth of accident data, and it has a list of probabilities of contributory factors occurring which could lead to an accident. And there's some high-level factors in there, 801 to 815, which are the various high-level hazards that we use, or as one way of doing it, we use that in terms of defining hazard categories. So in this instance, 802 is in effect derailment. So the rail had a compound fracture, disintegrated under the train. So there was no guidance path for that train. So there was an accident, 4 deaths and 70 injuries. So going back to hazards, causal factors, see up top right there, the diagram again, your causal factor there would be a compound rail break, which was a result of rolling contact developing in the rail. And the hazard was basically you had the opportunity, the forces imposed by the train onto weakened rail. There was no barriers to escalation because the ultrasonic testing regime at that time was inadequate. Therefore, you had the hazard, the opportunity, and the gap in the barriers to escalation, which resulted in the incident. So there was a learned industry response to that, which would be implementation of enhanced rail management in Network Rail Standard TRK 001. So TRK 001 then now becomes a code of practice that the industry needs to comply with in order to prevent the potential for that accident from happening again. Okay. Again, interesting concept of interesting example of some hazard identification. This is an example of a recent major station remodeling project. Interesting in that this is just a small part of it. It looks complex in that you have a new island platform, you have track changes and signalling changes that go hand in hand with that, and we also have changes to the existing platforms. But in actual fact, this project was a lot wider than just the station area itself, and there was a lot of signalling and track layout changes either side of the station area, which needed to be considered at the same time and risks assessed. So what were the challenges here? Well, you have the new interoperable island platform. So that introduces the requirement for consideration of interoperability. You have modified platform enter existing platforms. So how do we actually incorporate those changes within an operational station? You've got, as I mentioned, the track layout changes, and you've got a full re-signalling. So obviously a hazard identification process needs to take place. So we need to look at the interfaces between the station construction works, the CDM works, and the operation of the station itself. We need to look at the construction phasing. We need to look at the interfaces between the construction works and other operations. We need to look at the impact of the changes on the track layout, the signalling layouts. There's also some other interesting ones in that the new platform was being implemented on an area of former sidings. So the sidings needed to be taken out, and you had a brownfield site. So you've then got consideration of hidden hazards, so unexploded ordnance potentially, hazardous material, plenty of years of hydrocarbons, coal, oil being dropped onto the ballast over the years. You've got a disused subway that went under the track at that point. No one ever found it, as far as I'm aware, but it's there somewhere. and there's historic drainage arrangements that could potentially, if breached, result in pollution entering the nearby river. So a hazard identification act, or a set of hazard identification activities needed to take place to assess the potential for these hazards to be present, and mitigation during the construction and the commissioning phase to ensure that those hazards are adequately managed. Same project. One good way of going through identifying hazards is looking at the signalling scheme plans. The eagle-eyed amongst you might actually recognise where this is. Now, for those of you who don't understand scheme plans, basically anything red is new or changed, and anything green is infrastructure that's removed. So you can see here that there's quite a complicated, in fact, everything basically gets renewed, with the exception of with one overbridge, 2 under bridges, and a small section of double track just to the left-hand side of the diagram. So we've got lots and lots of new infrastructure coming in here. So one way of identifying hazards would be to walk through this from a driver's eye perspective, seeing what the implications of new signal positions would be. You've got a lot of new axle counters in there, so what's the implications of a train failing across a section? In terms of the maintainers, you've got new lockout devices going in. You've got an overbridge on the right-hand side with signage. Is the driver of a train coming towards that signage able to see it because of the presence of the infrastructure? All that sort of thing. And you can come out with a list of a huge number of hazards which have to go into the hazard record, of which I will talk later. Okay, so that's a pretty bewildering diagram, and you can spend a day walking through that, and that's just a small part of a scheme plan for a significant infrastructure change. Okay, even a relatively small change can have impacts. So here we have an extract from another scheme plan which shows double track plain line with very few changes, but it's quite interesting in that there are some quite there are actually some quite interesting potential hazards here, in that you've got 2 level crossings within a mile of each other. That's a stretch of line that goes between 5 3/4 miles to 5 miles. So you've got 2 level crossings, you've got a whistle board, and in between each, you've got two new signals. So someone's been sat doing the design work here, and I'm sure they've produced this scheme plan to be compliant with the requirements of the standard. However, as part of a hazard identification process, there are a number of, I would suggest, hazards here. Now, we have a signal here that is in very close proximity to a public bridleway. So there's potential for a train to be stood at this signal, someone to start to cross just at the same time as the train is powering away from that signal and about to cross the level crossing. So especially a person with restricted mobility might actually be in a position where the train could impinge on their passage across the crossing, which wouldn't be a very good thing. So this is an example of a new signal going in that might be compliant with standards, but I would suggest that it needs to be looked at and, if possible, moved further back, so that the crossing user has more warning of a train starting from a signal. Equally, you've got this dumbbell shape here is an axle counter, which is very close to the level crossing, and in fact almost looks as if it sits on top of the level crossing. So are there going to be impacts of metallic objects passing very close to that axle counter and disturbing the signalling system? What are the impacts of that? So that's quite an interesting example. That's a real example, and I would suggest they probably have changed it through an update of the scheme plan as a result of the hazard identification and risk management process that we have undertaken. Okay. Another means by which hazard identification can take place is through a context diagram. So this is a very useful, almost a word cloud that shows the scope of a hazard that considered a novel product subsystem for a piece of plant for use on the infrastructure in possessions. And the dark yellow section was the subsystem that we were considering in the hazard, and you can see how it actually interacts with the other product systems, the other components, and we went through all of these components and we looked at the functionality of these components, how it interacts with the people who are operating it, potential failure modes, that sort of thing. And you just go through from the subsystem and you gradually expand out to look at the product system. You look at the project work sites. So you look at all of the people on the work site operating, presence of infrastructure nearby, that sort of thing. Then on the outside of it, you look at the interfaces on the outside of the project, the signalers, maintainers, members of the public, existing signaling, other railway systems, power supplies, utilities. And on the left-hand side, you're looking at existing technical non-compliances, derogations that might be in place, impacts of possession planning, possession handback, line clear verification, that sort of thing. That's another very powerful way of going through and doing a very comprehensive hazard identification process for a novel product. Okay, mention the hazard records. Won't go into too much detail, but these are effectively the main means by which hazards that have been identified throughout the project are logged and are treated throughout the project. So you will identify the hazards, go through the risk acceptance principles, assign risk acceptance principles, and from that define safety measures, the requirements, define what the evidence should be, and verify that evidence has been collated. And the smaller spreadsheet extract here shows the safety requirements, which is it's a tab that enables you to manage your safety requirements and demonstrate the compliance has been met within those safety requirements. These can be large documents with many tabs, and it's often a full-time job to maintain these for larger projects. Okay, quick, conscious of time again, quickly whiz through this. This is the main part of having identified the hazards, which is the activities in the green box on the right-hand side. Need to assign the risk acceptance principles. There tend to be these codes of practice, which would be means of managing most of your hazards, because, as I say, the industry's had plenty of years' experience of defining these. So there's a lot of safety requirements that are defined in the codes of practice. You may have novel systems whereby similar reference systems might be the applicable risk acceptance principles. And if you've got really novel first-time implementation or changes have never been made before, you may wish to do explicit risk estimation, which can be qualitative or quantitative. But you really want to sort of, well, not so much avoid it, but it's not something to be undertaken lightly. And the preference would be to use established technology unless there's a route to introduction of new technology at a particular point of the change that you're making. Okay, and I mentioned the evidence, risk evaluation, derivation of safety measures, which are options for what you can do through the risk analysis process. Safety requirements are what you are going to do, is what you've selected, that are reasonable and can be implemented to control the hazard, so to be as low as reasonably practicable. Okay, so at the end of it, you need to provide the evidence that you are compliant with your safety requirements and your risk acceptance principles are fulfilled. So just mention about codes of practice. Mention that this you should be doing mainly as part of your business as usual activities. So you will be documenting evidence in compliance with signalling handbooks, signalling testing, signalling installation, signalling design, and the project as a whole will be completed for network rail projects. The entry into service checklist, which will in effect provide an index that demonstrates you've complied with the requirements for the network rail safety management system. Okay, quick overview of the role of the assessment body for significant projects. We're assuming that we have a significant project. Throughout the project, after the significance test, an ASBO will be appointed, and they will be checking that the CSM process has been followed. And I won't go through all of those, but basically the process that you followed is adequate and compliant with the CSM. The hazard record is complete. All reasonably foreseeable hazards have been identified. The hazard entries have been treated. Safety requirements have been defined, and evidence is available to close or transfer those hazards to other more appropriate actors. Okay. But the ASBO remains independent. You shouldn't be putting the ASBO into a position where they are they are overtly advising the project on the process that is being followed. It's up to the project to follow the process. The proposer of the change remains responsible for safety and takes the decision to implement the change, which in Network Rail will generally be the project sponsor. The project sponsor is entitled to disagree with the ASBO, not advisable, but if they do, they need to justify why they disagree with the feedback from the ASBO and document that disagreement. Subsequent audit, should the ORR require to do this, and they do have the power to do that. Okay, so your final activity in CSMRA is producing the safety justification, which is compiling the documentation that you've produced as part of the CSMRA, justification that all your hazards have been managed. That's all information that's contained in the hazard record. There's a high-level document called the Safety Justification Report, which is not a requirement of CSMRA, but it's certainly a requirement of Network Rail standards, or the standard, and it's actually good practice. It gives a good summary of the risk management that's been done, and in effect it provides a guide for the content of the hazard record. Okay, significant projects. Yes, I mentioned that for Network Rail, all projects, whether they're significant or not significant, needs to follow the CSM, and therefore all these documents will be produced for a Network Rail project, irrespective of its significance. So for a significant project, you'll have the independent assessment, and you will be required to produce, or have produced for you, a supportive safety assessment report by the ASBO. And again, the proposer remains responsible for the safety and takes the decision to implement the change. Okay, mention Network Rail. Network Rail has its own standard, which is well known to those of us who deliver CSM within the Network Rail projects. It includes a lot of very useful templates for the preliminary system definition, safety plan, project authorization strategy, and SJR, with very useful guidance within the forms themselves. So if you need to refer to those, I would recommend them because they're very useful. They give a format and headings that you can use to form the basis of your reports. Okay, just to note that it's not just that standard that may be applicable in terms of complying with CSM. The Network Rail acceptance panel process is covered by the suite of those standards. If you're introducing products, I did mention that I was going to go in to talk about product acceptance. So you'll be glad to hear this is the final, well, it's coming into the final couple of slides now. Network Rail has another standard 05 within that suite of standards that defines product acceptance. And also for new products, something that's coming in and is becoming more and more important is compliance with NRL2 RSC 0005, which seeks to demonstrate in compliance with Senate 50126 that the product design has considered reliability aspects, including demonstration of fitness for purpose through FMEA activities and that sort of thing. Final technical slide. Another extract from the Network Rail Standard, where this shows the relationship between the processes for acceptance of infrastructure changes, acceptance or introduction of new products, and introduction of new or changed vehicles. They follow a very similar process. And in terms of infrastructure changes, you'll see here that application of CSM fits within this process. It also includes links to the compliance with interoperability, which is managed through another standard within that suite. And the various outcomes are declaration of verification for interoperable changes. And for non-interoperable changes, you will be NRAP may delegate the decision-making process, the approval process, to a system review panel. Sponsor will, following the output of a system review panel, accept the implications of the change in safety profile through production and declaration of control at risk. Introduction of new products, yes, it's very similar insofar as you follow the process defined in 05, and ultimately you get a certificate of acceptance, which is then authorised by NRAP. And the same, very similar with vehicle changes or new vehicles. This is the compatibility process. Demonstrate that the vehicle is compatible with the infrastructure to produce a statement of compatibility, a summary of compatibility, which again goes through authorization through NRAP. So there's fields there worthy of presentations in themselves. And I'm conscious that I really have spoken far too long. So if you need additional guidance, there are guidance documents that are very useful on CSMRA that have been produced by the ERA, ORR, RSSB, and shameless plug for Ricardo's 1 and 2 day training courses, which you'll be pleased to hear concludes my presentation.
Lovely. Thank you, Paul. Thank you for taking us through that. So, can I open up the floor for any of our audience if you have any questions for Paul? Either please feel free to post them in the comments box or unmute yourself and ask the question verbally.
I think I've put them all to sleep, Liam.
No, I don't think that's true. I don't see any questions in the chat box. I'm not sure if it's. Can you see any, Paul?
Let me have a look. There's one. Please capture. That's your question, Liam. No, I can't see any.
Right. Oh well, must have been. You were very comprehensive then, Paul. And no questions from the audience members.
Or I've completely baffled them.
I guess you open to questions by email, Paul. If some should.
Absolutely, yes. Oh, here we go. Michelle Mullen. Hi, Michelle. Is there any intention to remove the need for CSM to apply for every project in Network Rail? I think that's a loaded question because yes, there is. The RSC 100.02 is, I understand, imminently going to be reissued. However, separately from that, what was Network Rail infrastructure projects, investment projects, has already put together a lighter version of CSMRA for their projects, which I'm not. I must admit I haven't reviewed recently, but as I understand it, it basically lumped quite a lot of the. It's basically simplified the application of CSMRA across the GRIP process, and I think that's actually going to be the basis of the new version of 100.02, which will tailor to the new or the replacement of the GRIP project governance process.
Okay, thank you, Paul. You have another question from Alistair Kennedy.
Hi, Alistair. Yeah, thanks for the question. What do you think the weaknesses of how the CSMRA process is currently applied? Okay, well, my opinions of this are you can often get into a position where you can't see the wood for the trees, because the requirements to identify all reasonably foreseeable sorry, Michelle's just another email. Right. Thank you, Michelle. Yes, I appreciate that. Yeah, good. Yeah, good point. Yes, sorry, Alistair. Yes, the requirement for all hazards to be identified, or reasonably foreseeable hazards to be identified, I think introduces the potential for the more interesting hazards and the hazards that have the highest potential to lead to a catastrophic accidents to be overwhelmed by many other hazards. So certainly with the hazard identification that I've been involved in undertaking, we've identified lots of hazards associated with train collision and derailment. So you're spending a lot of time processing all of those hazards, but there's a risk there that you might actually miss the combination of factors that lead to that hazard, or don't fully appreciate the significance of one or two hazard line entries that are in your hazard record that you may have misinterpreted, you may not be fully appreciating, and you could miss that. I'm trying to think of an example where that actually has happened. Can't think of anything at the moment. Things keep springing to mind with regards to the fact that you are making a change. The implementation of the change in itself can introduce other hazards that you might actually miss. I'm not entirely sure that CSMRA, following the process to the letter, is particularly good at necessarily identifying changes to existing safety profiles for other interfacing systems. So, yeah. Hi, Alistair.
Sorry, I'll mute myself.
Okay, is that does that answer the question?
Was saying thank you.
Yeah, that's fine. Thank you, Alistair.
Well, I totally agree. I think that the danger is that it is a real problem because so many of the requirements are closed out by compliance with standards that it's you end up, and then you've got to provide evidence that they comply with the standards if you're not careful, and it becomes a whole massive task in its own right. And yet the key risks, and if you think about what is unusual, novel, or in the way the system's being applied, that's usually where the risks lie, or something novel about the system itself. And you can, as you say, the attention is, the effort is dispersed over such a large area that the key issues don't really get as much attention as they perhaps deserve.
Absolutely, yes, yeah, you're absolutely right. A very, very good point. Yeah, yes, because the majority of your hazards are managed through the standards and compliance with business as usual activities. How do you actually pick up those really interesting hazards that are not? Do you actually lose it by do you lose those hazards by assuming that a code of practice will manage them? Do you need to go into them any further?
Yeah, thank you, Paul. That's great.
Okay, time for one more question if anyone has one. No. Okay, wrap up then. So I think that leaves to me, Paul, to thank you for the presentation tonight, especially noting that you drew this together at short notice. So thank you very much for that, for talking us through helping us to demystify and talk us through the process of the CSM. You looked at how the CSM applies to projects and how to undertake a significance decision to understand the extent to which it applies. We looked at preliminary system definitions, and you gave us some tips on how to identify hazards, and then looked at capturing them in a hazard record and analysing them and driving them through to defining safety requirements. So thank you very much for that comprehensive overview of the CSM. And I'd like to invite our members to turn on their cameras or microphones and thank Paul in the usual way with a round of applause.
Thank you all. Yeah.
Last one, Paul.
Thank you,
Yeah.
Paul.
Yeah.
Just a
Drop me a line if
reminder,
you need any more info.
our next Nottingham Derby section meeting is going to be Wednesday, the 17th of March, where we'll hear from Andy Franklin of Network Rail, and he's going to talk to us about the history of CWR and hot weather management of derailment risk at switches and crossings. So I hope you can join us for that meeting too. So have a good evening, everyone, and goodbye.